Hello again, here's me, still mucking about, so to speak. I'm going to do a little YouTube video today on something a bit different to what I normally do. It's more about what I used to do when I was working, rather than when I retired. And it's to do with this little bit of kit that is in the back of my workshop, and people come and go here and they ask about it and they say, oh, it's something that you needn't bother about, you know, or something. But I thought, well, I'll make a video about it for two reasons. One is that if anybody comes and asks, I say, well, I made a video about it, it's on YouTube, and if you go and watch it, it'll tell you most of the things that I could explain about it. So that's one thing. And the other thing is that I probably will sell this little device that operates that, and put it on eBay, and therefore if anybody wants to buy it on eBay, they can also look at the YouTube and come to a decision on it. Now then, what is it? Well, this little section here is part of a water turbine, a homemade water turbine, because we've got a leak that runs through the property, and I put a water turbine in, and this is the part of it. This is the generator side. The turbine side, which will water run through, is on the other side, and that is outside the workshop, and I'll put a little photo of it if I can. And therefore, but the generator side is what we're interested, because what this does is this kit here is connected to it. There's no electrical connection at all between here and there. That is the mains, and there's a belt there, and that drives the generator. And all this is doing, this electric motor is doing, is simulating the turbine. Is showing as if the turbine is running it, so that we can take measurements of that and thereby determine the best speed at which this runs for the most efficient use of the electricity, or the generation of the electricity. So that's it. So that's what happens. Now then, normally the generator is there, the electricity comes through here, goes up to the house, and then we make use of it up there. I've added this to it here in the workshop because I want to simulate using power of it here instead of at a distance. So I put a three-phase rectifier there to rectify to DC, which is quite normal, and also put a series of switches on here which will switch these on independently, and that's a spare. That's 1, 2, 3, 4, and this one is an overall control one. This switches it on and off, and I'll explain that a bit again in a minute. And so therefore we can, by running that, we can see, I can determine and putting down on graphs and things like that, and tables, how the turbine generates on varying loads and at varying speeds. There we go. How do I get varying speeds? Through these two. Now then, this is a variable frequency drive. They were made about the end of the 1950s, when solid states come about, like transistors and diodes. Must have taken a lot of working out, but somebody worked it out, probably a team, and once they got it down, then they managed to get it to run at varying speed, and they've also added these characteristics to it as well, which is good. And that is the motor that drives it drives. Now then, how it works is it takes single phase and converts it to DC. Now, why don't you use single phase for varying drives? Because you can't. But you can if you use three phase. So I won't go into that at all, but it's easier to use three. Well, you can't do it any other way. So what that does, it takes the single phase into there, converts it to DC, and then it changes the DC again into three phase. And therefore, if you change the frequency of three phase into a three-phase motor, then it varies the speed of the motor almost infinitely. So it varies the frequency. It varies the frequency of the three-phase on these controls. And this is a little three-phase motor. They're quite cheap and cheerful, I think. I don't know. And that will vary. It'll vary the speed of that infinitely. So therefore, running through these pulleys here, and there, if we alter the pulleys when we know what speed we want to go at, we can therefore put the turbine together and know we were running it at maximum efficiency. So that's the way it works. So what we need to know is how this works. So it converts it to DC, and then it sends out 3-phase into the motor, and that will run that at this varying speed that I said. So let's go ahead and do that, shall we? Switch this on, leave it settle up, put that to there, and that starts up. Now then, that isn't very fast, but we got a potentiometer here, which is a variable resistance, a potentiometer, and if we turn it up, you see, that's more closely to what the turbine would be running at. And so, what we can do then, so if we put a load onto that onto that generator, then we can determine the voltage that we get out. Now we've got a set of switches here. One is a spare, and then we've got a switch for 8 light bulbs, 4 light bulbs in as a load. So if we switch them on, 1, 2, 3, 4, and that is the on switch, which controls all them loads. And if I was to switch that off, it would switch the whole lot off. I don't want to do that because the DC, it's a DC, and these are AC switches, and AC switches don't like DC very much. So that's it. So that's it. Now then, if we were to simulate the load, we can, by turning this, we can change our speed to any speed we like. From something going down to, even down to that, up to that speed. We can actually double the frequency on that if we want to and go fast, but that's fast enough. That's about the speed that we want. So that's it. Now then, it's got another few characteristics that they developed over the years, and if you look at switch, you can switch it off there, and it stops slowly, you see, and then you can switch it on again, and it comes up to speed, and you see how slow it does? It stops slowly. Nice for a machine if you're running a machine off it, because people do run machines of them. Whereas if you didn't do that and you had to switch it off, like I said, don't like doing this too much. If you had to switch off like this, you watch the difference. Sort of comes to a juggling halt. Now that's switched itself off now. Now that's got a fail-safe device, so you can't switch it on like that until you go back to 0 and then switch it on. That's in case the electricity fails. So that's it. So there's the characteristics. It's also got the characteristic of, if you were to, it will run that in reverse if you like. And this is how it does it, by slowly stopping and then going in reverse. So it will slowly come to a stop. Though I'll switch it right over to reverse now. Slowly to a stop. Starts up and goes the other way. And then what you can do then is switch it over and it will do the same the other way. So if you had a machine that was doing a process and then you wanted it to come back and you didn't want to, with just that little single device, you can affect that. So you can control all sorts of things with it. You can control fans, like a fan. You can control a small lathe where you want to vary the speed of a lathe for different cutting speeds, and that. You can vary for a device or a planer or anything really, and it can be done automatically or you can do it on your own. Also, inside here is a set of terminals, and you can take all this system apart from that one. You can take that and put a remote section, so you can run it from here or remotely. So if you had, say, a lathe, a small lathe is probably the most simplest thing. You could put switches similar to those on the lathe, and you just switch it on the lathe, and you could turn it. You don't have to alter it like I do. I alter the pulleys on my lathe when I want to do some drilling. You don't have to do that. You just turn it down on the lathe, and then you go up. Say you're drilling a small hole, you have to drill at that speed. If you're drilling a large hole, you turn it down to that. You do it on the lathe, and if you want to turn it backwards, if you're screw cutting and you want to do it, it will do that. So that's the characteristics of it. It's all a very good tool, and I've had it for a long while. I've set this up, and I sort of, because we got the solar panels, lost a bit of interest. And I may be moving, so I thought, well, I'll put it on eBay. But I thought I'd do this so that, well, you folks can see it, and also anybody wanting to buy it, they can see it as well. So that is, for that, the variable speed drive, or variable frequency drive, variable speed drive, and the 3-phase motor, I'll put on eBay. Actually, I probably will sell the whole turbine as well if somebody wanted it. I mean, the turbine is outside, and the control gear for the water is there as well. And the turbine and the generator all locks together very, very effectively, and it's on the Elite. I put it all together. You push it towards the intake. You put a pin in to stop it, and that's all you got to do. You take it down. Just put the two pieces together. It's on a rail. You push it up till it fits into the 6-inch pipe. The socket fits into the 6-inch pipe. Put a pin in the rail so that long it doesn't come back. Otherwise, it get covered in water, and then we'll switch the water on, and away you go. So that's it. So I'll just show you roughly about how this works with regard to those. Yeah, should we do that? So I want to turn it on. That about 150 watts. I think it's about 600 and something watts there. Turn that up, and while I measure the characteristics, is if I switch that. That's set to 1000 volts DC, and here I got a 3-phase rectifier, because that is actually a 3-phase generator. That's not uncommon these days. Comes into there. The first thing I want to do is do what they done, is put it back into DC. So if I go on there, see, that's now running at 196. But if I turn, say, 2 of those off, that will now, the voltage will increase because it's got less load in it. It's now 229. Let's turn another one on. See that? 268. And what I've got here as well, turn that off. What I've got here as well is I've got 1, 2, 3, 4 for the bulbs. And that's the on-off switch. That controls all of those. And in there, I can put, but it's not on voltage, it's on current. And I have got a voltage and a current meter. And I put my current meter into 2 terminals here, you see. Now I press them, I can press little probes into the terminals there. And then when you switch that off, like that, all the current has got to go through your meter. And so therefore you get the current. The amount of current that has been used, and on the other meter, this one, the voltage one, you get the voltage that's been used, that's been generated, and then you can work out the power, because you've got the voltage quantity and you've got the current, and therefore if you multiply together, W equals V times I, which is wattage equals volts times current, it gives you the power. So voltage is energy, but wattage is power, and that's what you want. The watts, how many watts? Wattage is what you're interested in. So that's how it works, and I just put it together. So I'll put it on eBay probably tonight, and see how it goes, and we'll take it from there. So I hope that's given you some idea of the silly little things I do, and but it all makes life that much more interesting, doesn't it? So that's it. I don't think there's anything else we can add to that. That's pretty well explained it, and it saves me from explaining it anymore. What comes with this? It's a good piece of kit. It's not it's a good quality one. There are various inverters or variable speed drives that are a little bit unreliable, but this is an industrial one, and it comes with there's the amount of characteristics that it's got about 50 pages of what you can do with it. You can invert it. It's an all singing, all dancing piece of kit, and it also comes with a disc that you can put in a computer, and on that disc is all that's in there as well. So it's pretty well. Nobody should get stuck with it. and I've used it many times with getting the characteristics. I've got loads of information on that now, so so that's it. So it's pretty comprehensive, and I hope somebody will make good use of it. As I say, you can use it for loads of things, mostly in engineering, or anything where you want to, or for compressing air or fans or heating or whatever you want to think about, where you're using the motor. And that's what it does. It varies that motor to an infinite degree, and it varies the rotation as well. So there we are. So I'll leave it like that, and I'll put it on tonight, and hopefully it'll look okay. Okay, bye bye.